Guys, Mr. Bowman here. In this video, we're looking at 2.6 algebraic concepts. We're focusing on all the excellence questions from the 2017. In the link below, we've got question 15, which was the first question, or the first excellence question from that exam. So let's get into question 15. We've got a square-mounted photo on a square piece of card. So that grey thing will be the piece of card, and obviously the photo in the middle is going to be the photo that they've referred to. The border around the photo has a consistent width. That makes sense given it's a square. The photo has a length of n-2, so we've been given that in the diagram, and the side of the card 2n+6, also given that in the diagram. If the total area of the border is 200 centimeters squared, find the width of the border. So we're trying to find that grey portion. What's that total area? And that total area is going to be the area of the card minus the area of the photo. The area of the card will be 2n+6 squared, so that's base times height. And I'm now going to take away base times height for the photo. And when we subtract those should get us to the 200 centimeters squared that the question referred to. I've got one letter here, just n, so I need to adapt some kind of solving strategy to go ahead and find out what that n is. I'm thinking it's going to end up being a quadratic if I expand both of the brackets. So let's put those into double brackets, 2n+6, 2n+6, and then we're going to take away n-2, n-2. That there needs to come to 200. Now I'm going to expand the first set of double brackets. That's going to be 4n squared plus 12n minus or plus 36. And the last part here, noting I've circled the minus sign in front of it as well. This is probably where some mistakes are going to come into it. So I'm going to go minus, and I'm going to have a bit of an open bracket, and I'm going to put whatever this expands to inside that open bracket. It's going to be n squared minus 2n plus 4. All of that comes to, I've written 0, but that's meant to be 200. Now that I've done that, I'm now going to expand this single bracket to reflect that minus sign. And I'll probably do some simplifying at the same stage. So 4n squared plus 24n, that comes from the two 12n's up there, plus 36. And then I'm going to go minus n squared, which is minus 1 times n squared. And there comes to negative 4n squared times negative 1 is positive 4n. And then I'm going to have minus 4 equals 200. I'm now going to group everything in this expression, which I can. And I'm going to start off 4n squared minus 3, or 2n. That's going to be 3n squared. I've got 4n plus, so 24n plus 4n. That's going to be 28n. And then I've got 36 minus 4. That's going to get me to plus 32. And that there is going to be equal to 200. I'm now going to shift that 200 to the other side by doing a bit of subtraction to both sides, leaving us with 3n squared plus 28n minus 168. That there comes to 0. And this time around, we've now just got a quadratic as we expected. We now need to solve this quadratic. You can mess around with maybe trying to factorize, potentially grouping method, or even the quadratic equation, but I'm going to jump straight into the graphics calculator, ABC. So that's going to be 3, 28, negative 160. And when you get that, that tells us n1 is going to be equal to 4.15, and n2 is going to be equal to negative 13.49. Both of those had a 2dp rounding. So we've now got to think, we've got a quadratic. Sometimes there are false answers, and in this case, there's probably going to be a false answer because n can't be two numbers. And if you think of that bottom number, if we put n into 2n-2, that's going to be negative 15.49, and we can't have a negative measurement in relation to a photo, so we're going to eliminate n2. n2 equals false answer. Because we can't have a photo, of negative 15.49, and we are dealing with centimetres as our units. So I've ignored that, which means N1 of 4.15 is our final answer. So I'm now got to think about the width of the border. So I've solved N, but I haven't actually found the width of the border. And the width of the border, if you're going across this way here, it is going to be 2n plus 6. We're going to take away the n minus 2, and that will give us the addition of two parts of the border. Then you're going to chop that number in half. So that there will be an expression for the width of the border. I'm now going to substitute, or maybe I'll do a bit of simplifying here actually. That's going to become n plus 4. Oh gosh, sorry, no, n plus 8. Because we're going to have negative times a negative, which becomes positive. That's going to be halved. We're now going to substitute 4.15 plus 8 divided by 2. And that's going to get me to 6.075 centimetres. So that there is the width. So width of border, which is not have a good time spelling that. There we go, width of border, and then we got our final answer. We are now looking at question number 16. A teacher has hired a school bus for $560, and that's for a day trip with students. The cost of hiring has to be shared equally between the students, and all the prices increased by $1.50 for those students. How many students finally went on the trip is the question. So this question's a little bit hard when you don't know how to get into the question. But we're going to start by just defining what variable or what we're actually trying to calculate. So x is going to represent the number of students who go on that final trip. So students on final trip. Which of course then means x plus 3, because don't forget 3 of them pulled out. They were the original numbers. So original number of students. So that's the starting point. And once you got that, I do think it makes a bit more sense. We've then got to start thinking about this $1.50. So we know the price has been increased by $1.50. So what that means is if we have the new price and we take away the original price, that there should get us to 1.5. So we've now just got to come up with an algebraic expression of the new and the original price in terms of the x and the x plus 3 that we've talked about. And the way you'd be doing this is, so the new price is going to be $500 divided by x number of students. That's the students on the final trip. And we're then going to take away 500 divided by x plus 3. And that was the original price shared between x plus 3, or the original number of students. And that there should be equal to 1.5. We've now really just got an algebraic fraction. And what we're going to do is we're going to use the crisscross smiley face method just to simplify that. So we're going to start off with by doing bottom times bottom. So that's going to be x plus 3. I'm then going to multiply by the crosses. So that's going to be 560 x plus 3 minus 560x. And all of that should come to 1.5. When we get into simplifying this, we're going to have to expand the brackets here. That's going to be 560x plus 1,680 minus 560x. That there should be equal to 1.5. That's divided by x plus 3x as well. So that was the denominator. We can see the 560x's, they cancel each other out. That's leaving us with 1680 divided by 2x, x squared plus 3 equals 1.5. And we've got 1680, that's 1.5 x squared plus 3x. And once we're at this stage, that's beginning to look like a fairly simple quadratic. So let's expand that bracket. So we've got 1680 is equal to 1.5 x squared plus 4.5x. I'm now going to take that there over to the other side. That's going to become negative. So 0 is equal to 1.5 x squared plus 4.5x minus 1680. We can mess around with factorizing and other solving methods, but let's just jump straight into the graphics calculator. 1.5, b is equal to 4.5, and c is equal to negative 1608, or 80. And when we get that into the calculator, that tells us x1 is going to be equal to negative 35, and x2 is equal to 32. We're going to ignore that first one. Clearly, there wasn't negative 35 students, so we're going to ignore that. So that means, therefore, 32 students went on the trip. There we go. So that wraps up this question. Fairly easy one, but really challenging to set the equations up initially. We are now on to question number 17, and a computer depreciates. So depreciate's a key word because that means it's going downhill from 4699 to 1500 over 4.25 years. If the computer was originally valued at that, it can be modeled by this particular equation. Find the computer's value after 6 years. We're going to start off with by writing down that equation that they gave us. So y is going to be equal to AR to the power of t. And what we know is that y represents the current value that we're aware of. So that's going to be 1500. The a represents the initial value, which is 4699. The r relates to the rate it's depreciating. So what I'm going to do is I'm actually going to change that to 1 minus r, just for me to calculate or get straight to the depreciation rate. And then finally, t, that there was 4.25. I'm going to substitute all of that in. The only variable that's going to be left is r. I'm going to go ahead and then find out what r is. So 1500 is equal to 4699 times 1 minus r to the power of 4.25. I'm now just going to go ahead and use ordinary algebra to get into this. So that's going to be 1500 divided by 4699 equals 1 minus r to the power of 4.25. This is a power. I'm going to move this to the other side as like a root. So that's going to be 4.25 root of the fraction. That's going to be equal to 1 minus r. I'm just going to move the r over here as positive, which means that root that we have there will move over to the other side as a negative. So that will leave r equals 1 minus the 4.25th root of 1500 divided by 4699. And then we've got r is equal to, plug that into your calculator. Don't forget about the bracket sitting inside that square root. If you are putting into the calculator, 0.2356, and that they had a 4 dp rounding. So what that means is it's losing about 23-24% of the value every single year. So at this stage here, you probably got yourself a merit because you haven't actually answered the question about the value at 6 years. And this is when we jump back to the model that we were given to. We were trying to find the value after 6 years, which is going to be y. So we know the original value, 4699, 1 minus that rate that we came up with to the power of 6, because we're looking for 6 years. Basically, plug that into your calculator, and you're going to get $937.41 to DEP rounding. And by chance, that's the bell going just as we finish the question. What good timing. We're now on to question number 18, and fairly straightforward question in terms of length, I guess. Make P the subject of this formula. So let's jot down the formula, 81, and then the power is px divided by q minus 3, and all of that comes to 243. So a question that we're going to have to deal with, but the thing I've noticed is 81, 243, they are both numbers which have a power or a base of 3 and a bigger power. So 81 is actually 3 to the power of 4, and that there is to the power of px divided by q minus 3, and 243 is 3 to the power of 5. I'm now going to expand the brackets on the left-hand side. So that means it's going to be 3 to the power of 4 px divided by q minus 3 equals 3 to the power 5. The base ones are the same. They can cancel each other out. You also could have logged both sides, and then the log 3 would have canceled each other out as well. That means 4 times px divided by q minus 3 is going to be equal to 5. I've now really just got a linear equation. I'm just going to do a bit of final rearranging to get my answer. That includes expanding the bracket. So that's going to be 4px divided by q minus 12 is going to be equal to 5 plus 12 plus 12. 4px divided by q equals to 17. Just a reminder, I'm trying to make p the subject. So let's go times q times q. Well, that's a bad q. Let's redo that. We've got 4px is equal to 17q. I'm then going to go divided by 4x divided by 4x, which means p is going to be equal to 17q divided by 4x. If you can get through all of that, definitely worth an excellence mark. And the trick really was switching it to that base of 3 for us to then be able to cancel out. You also could have just logged both sides. And then again, unknown power is normally a giveaway to log as well. We are now looking at question number 19. And again, really short question, but we've been asked to find the values of k for which that expression is always greater than 0. So what we know, let's jot down the expression kx squared minus 12x plus 5k. We've been asked when that is greater than 0. So to put it simply here, we've got a quadratic. And what we know about quadratics is we know the expression will always be greater than 0 when b squared minus 4ac is less than 0. That is when it's a negative number, which means there'll be no solution. So it'll never be equal to 0. It'll always be above 0. That's what we're looking for. From our quadratic, we know that a is going to be equal to k, b is going to be equal to negative 12, and that c is going to be equal to 5k. So we're going to plug that into our discriminant. B squared minus 4ac, when is that less than 0? That's going to get us to negative 12 squared minus 4 times k times 5k. When is that less than 0? And we simplify that, we're going to get 144 minus 20k squared. When is that less than 0? Just a reminder, we can't really solve quadratic inequalities, but we can visually sketch it with the x-intercepts to find out what values would meet that criteria of being less than 0. So as a equation, that there is equal to 0. So when's it equal to 0? This will be the x-intercepts. I'm going to make it positive just because I always do silly math errors when the x squared or the k squared or whatever is negative. There we go. So again, grab into your calculator. A is equal to 20, B is equal to 0, C is equal to negative 144. That tells you your two k values. K1 is equal to 2.6833 and K2 is the negative version of that, 6833. Both of those there I did a 4dp rounding to. That gives you information about the x-intercepts. So what we're now going to do is we're going to now that we've got our answers, we're going to jump back to that inequality that we're dealing with. And we're just trying to sketch it to see what that visually looks like. And there's our x and y axes. And key thing to note, the k squared has a negative coefficient, which means it's going to be a negative parabola. So I'm just going to sketch a rough negative parabola, not a good one. And I've got the two intercepts from further down. So that there's going to be negative 2.6833 and we've got positive 2.6833. We've now got to think, when is that expression less than 0? So when are there no solutions? And it's when it's below the axes. So that means the expression will always be above 0 when, and the two criteria, so we know that k has to be more than less than negative 2.6833, or, so we'll get rid of that, or when k is greater than positive 2.6833. So that wraps up that question. Hopefully it makes sense. We are now up to question number 20, final question from the 2017 exam. Find the values for m when this particular equation has one solution. So we're going to start off with that idea of one solution, and that is when the discriminant, so we have one solution when that discriminant is exactly equal to 0. 4b squared minus 4ac is equal to 0. The issue is we don't really have a quadratic. But if you look at the powers, you've got x squared over here, mx minus 3 over there. You can kind of see where a quadratic can result with a bit of simplifying. So what we're going to do is we're going to work on the equation to see if we can get a quadratic. Let's jot that down. 2 to the power of mx minus 3 is going to be equal to 8 to the power of x squared. I'm liking this because that 8 is 2 to the power of 3, so I'm probably going to cancel the powers. I could also log both sides, but I think cancelling the powers is going to be best here. So that's going to be 2mx minus 3. That's going to be equal to 2 to the power of 3, all to the power of x squared. That's going to be 2mx minus 3. That's equal to 2 to the power of 3x squared. The 2's cancel. Mx minus 3 equals 3x squared. So those 2's are gone. Definitely a quadratic. Now let's make it equal to 0. 0 is going to be equal to 3x squared minus mx minus 3. Let's pull out the a, b, and c values for the discriminant that we're trying to work towards. A is equal to 3, b is equal to negative m, and c is equal to negative 3. Sorry, I just realized that there should be plus 3, which means that's a positive 3 there, isn't it? Yeah, so minus 3 does become plus 3. Okay, so we're happy with that. Let's now plug that into the discriminant. So we know that b squared minus 4ac must be equal to 0. We're going to substitute away. So we've got negative m squared minus 4 times 3 times 3. When's that equal to 0? We've got m squared minus 36. We've got m squared equals positive 36. M is going to be equal to plus or minus the square root of 36. M1 is equal to 12. M2 is equal to negative 12. Oh gosh, that's terrible math, isn't it? That should be 6 and negative 6. So what this tells us is the equation that we have will have one solution when that m value is 6 or negative 6. So therefore, our equation will have one solution when m is equal to 6 or when m is equal to negative 6. So that wraps up all the excellence questions from the 2017 exam. In my view, this was definitely the easiest exam in terms of the excellence questions. Thanks so much for watching, guys. Now let's get into heaps of practice.